The graph of the function f consistent of three line segments in a quarter of a circle is shown above. Let g be the function defined by g of x equal to thingy 1x f of t dt. Find the average rate of change of g from x equals -5 to x equals 5.
We're gonna use the thingy, right, the integral. All right, so average rate of change is gonna be AROC. And AROC is basically the slope equation. And our slope equation is, we have g of 5, oh, it's too low, minus g of -5, all over 5 minus a -5. And then we need to go ahead and plug in some values to find g of 5 and g of -5. And because I'm thinking ahead, I'm gonna go ahead and find the areas on the top. So if I were to find the area of this triangle, it is base times height divided by 2, right? So my base is 3 times 4 divided by 2 is how many? 6. For this one, I have a circle with, let's write out pi r squared. The radius is 2, so really in the end it's 4 pi, but since I'm wanting a quarter, we have what? Just a pi. And then we have another triangle. Base of 1 times the height of 2 divided by 2 is how many? 1. And then for this piece, let's use our formula for the trapezoid. Base 1 plus base 2. I think I start with, yeah. Base 1 is going to be 2 plus, is that 4 units? 1, 2, 3, 4. Divided by 2 times our height is what's connecting it, 4. And there's a faster way to go about this problem. What is 4 divided by 2? 2. What is 2 times 6? 12. So this is going to be 12. So let's put in the g of 5. And our equation is given. G of 5 is equal to the integral from 1 to 5 of f of t dt. So 1 to 5 is going to be, we have to first make sure, does 1 come before 5? So as long as it's numerical, everything above is positive, everything below is negative, yes? So in this case, from 1 to 5, our value is 12. But then something unique happens for the -5. So integral from -5 to 5, oh, 1 to 5, silly. 1 to -5, I mean. I'm just not reading the equation. Right here. So 1 -5 ft of dt. So then let's kind of discuss. Does 1 come before -5? So if it's in the wrong order, that means everything above this time is negative and everything below is positive. Good? Okay? So if we're looking at it from 1 to -5, I'm adding the 6, the pi, and the 1. So that's going to be 6 plus pi plus 1. Now let's plug everything in. So I have g of 5, I got 12. Minus, always use parentheses because the distribution happens almost all the time. We have pi plus 7. All over, the bottom's going to be 10. So our final answer for this one is going to be when I distribute. 12 minus 7 is how many? 5 minus pi over 10. If you want to separate the two fractions, you can, but just leave it like this. Because if it's on free response, you want to try to not simplify as much as you can. Okay? So let's look at our sentence stem. Always steal the sentence stem from them. So I'm going to write all that is blah. So the average and the common abbreviations you may also use. You know what? Let's write AROC. That is our variable. The AROC. Oh, my whiteout's like, no. The AROC of G from x equals -5 to x equals 5 is the value we found, 5 minus pi over 10. So here's our breakdown. This alone is going to give us like 3 points, which is kind of nice. When they're stingy, they'll give you 1 point, which is going to happen on part B. So knowing the average rate of change formula is going to give you 1 point. And having the sentence with the final answer is 2 points. They're not even separating it. 2 or none. Okay? What's up?
Does 1 minus pi over 2 also work?
1 minus pi over 2. Where's the 1 coming from?
To simplify the 5 over 10.
Right here?
1/2.
Yeah,
If you do 1/2
yeah,
minus pi over 10,
yeah.
it also works.
Okay.
Okay, let's go on to part B. Kylie, go ahead and read part B.
Find the instantaneous rate of change of g with respect to x at x equals 3, or state that it does not exist.
So instantaneous rate of change, IROC, is when we have the derivative. So I'm going to write out the original equation from the top. So they gave us g of x is equal to the integral from 1 to x, f of t dt. So IROC is basically g prime. It is a derivative. So if I say g prime, then that's going to give me just f of x. Because when I derive the integral, they cancel each other out, so we just have f of x. So they're asking us to find when x equals 3. So when I plug it in, we get g prime of 3, which is also f of 3. And we have that graph. So on our graph, when x equals 3, what is my y value? Boom. And that's why on this problem, they're a little stingy on only 1 point. So then let's go ahead and steal the sentence stem. Oh, my, of g. My ink is running out. I'm going to say the IROC of g. And then they say with respect to x, let's write all that out. Write more than you need. With respect to x at x equals 3 is 4. So if you feel like you're being annoying and you're just writing too much, it's okay. It's better for them to see it than not see it at all, even twice, okay? So then the stingy part here is the whole sentence with the right answer, 1 point. So mean, huh? Okay, let's go on to the next one. Okay, on our next one, Alex, let's read.
On what open interval, if any, is there a graph of g concave up? Justify your answer.
Okay, so my g was integral of f. Concave up is right here, correct? So that's when I know the function is increasing. So I'm going to put on here, it is concave up, this is just my side note, when g prime of x is increasing. So I'm going to go to my graph and see when they're increasing. So let's highlight. For me, I'm going to highlight. It is increasing here, and is increasing here. So how many unions do I need then? Probably 1, okay? Unless you write it in inequality form. So I'm going to go ahead and write out. Let's steal the sentence stem. The graph of g is concave up, and then I'm going to say on certain interval. The graph of g is concave up on the interval. So if you look at the interval from the beginning, it's from -5 to -2 and 0 to what? 0 to 3? I think I'm going to go ahead and be consistent. Since they're using inequality form, I'm just going to be consistent with that. You don't have to. If you want to use the other notation with the union, you're more than welcome to. And then the reasoning is always needed because g prime of x, which represents f of x, is increasing. And this one, they want the whole thing, 2 points. And again, like I said, FRQ number 3, it is doable. Okay, so if you were stuck at some point and you're like, okay, it makes sense, give yourself a circle. Okay, on part D, Hannah, let's read.
Find all x values in the interval -5 is less than x, which is less than 5, at which g has a critical point. Classify each critical point as the location of a local minimum, a local maximum, or neither. Justify your answers.
So we know we have a maximum when it's going from positive to negative, and we have a minimum if it's vice versa, right? So let's write some note on here, on the very top. First of all, we know critical point happens when the slope is equal to what? 0, very good. So I'm going to write on here, there will be a minimum if it goes from negative to positive, and there will be a maximum if it goes from positive to negative, just my side note. So the first thing is we have to set it equal to 0. So let's write it in here, g prime of x, which is representing f of x, must equal 0. And let's see at how many points or at 1 point. So go to our graph again. We have 0 here and 0 here. So the first 0 is at negative what? Second one is at positive 1. So I'm going to write on here at x equals negative 2 and then x equals 1. And I'm just going to go ahead and give you the point system. Knowing that g prime of x, which is representing f of x, is equal to 1 point. And then also knowing that these 2 points are at 0 is another point. But you can't have just one, it has to be both. So then let's analyze that. When I analyze at 2, is it changing sign? Is it going from negative to positive? Or just still negative to negative? So it's going negative to negative, so it's not changing sign. That's not a local minimum or maximum. But at this point, negative to positive, that's going to be a local what? Minimum. When I go down first and go up, I'm creating a minimum. And let's write in, for this one, we need explanation for both of them. So I'm going to use local minimum at some point, maximum at some point, and neither at some point. So let's put on here, G has no local minimum or maximum. At which point?
-2.
At x equals negative 2, and you have to reason it. And the reasoning is because g prime of x, which is f of x, is not changing what?
Sign.
Good. Is not changing sign. Changing signs. Hopefully if it's singular or plural, they're not that picky. I doubt it. And then at 1, was it a max or a min? Min. So G has local minimum at x equals 1 because, again, always the reasoning, because g prime of x, which is representing f of x, is changing from what to what? Good. Can I just say changing signs? No, because it could be a max. Changing from negative to positive. So 3 points are from here. I already gave you the first one at 0. Second one, knowing what those two values are. And you have to have all of them, another point. And that should tally up to 9.